Local validity as a key to sanity and civilization, Part 1. 0. TL, Doctor, there's a similarity between these three concepts. A locally valid proof step in mathematics is one that, in general, produces only true statements from true statements. This is a property of a single step, irrespective of whether the final conclusion is true or false. There's such a thing as a bad argument even for a good conclusion. In order to arrive at sane answers to questions of fact and policy, we need to be curious about whether arguments are good or bad, independently of their conclusions. The rules against fallacies must be enforced even against arguments for conclusions we like. For civilization to hold together, we need to make coordinated steps away from Nash equilibria in lockstep. This requires general rules that are allowed to impose penalties on people we like or reward people we don't like. When people stop believing the general rules are being evaluated sufficiently fairly, they go back to the Nash equilibrium and civilization falls. The notion of a locally evaluated argument step is simplest in mathematics, where it is a formalizable idea in model theory. In math, a general type of step is valid if it only produces semantically true statements from other semantically true statements, relative to a given model. If x equals y in some set of variable assignments, then 2x equals 2 years in the same model. Maybe x doesn't equal y, in some model, but even if it doesn't, the local step from x equals y to 2x equals 2 years is a locally valid step of argument. It won't introduce any new problems. Conversely, xi equals xz does not imply y equals z. It happens to work when x equals 2, y equals 3, and z equals 3, in which case the two statements say 6 equals 6 and 3 equals 3 respectively. But if x equals 0, y equals 4, z equals 17, then we have 0 equals 0 on one side and 4 equals 17 on the other. We can feed in a true statement and get a false statement out the other end. This argument is not locally okay. You can't get the concept of a mathematical proof unless on some level, though often an intuitive level rather than an explicit one, you understand the notion of a single step of argument that is locally okay or locally not okay, independent of whether you globally agreed with the final conclusion. There's a kind of approval you give to the pieces of the argument, rather than looking the whole thing over and deciding whether you like what came out the other end. Once you've grasped that, it may even be possible to convince you of mathematical results that sound counterintuitive. When your understanding of the rules governing allowable argument steps has become stronger than your faith in your ability to judge whole intuitive conclusions, you may be convinced of truths you would not otherwise have grasped. 2. More generally in life, even outside of mathematics, there are such things as bad arguments for good conclusions. There are even such things as genuinely good arguments for false conclusions, though of course those are much rarer. By the Bayesian definition of evidence, strong evidence is exactly that kind of evidence which we very rarely expect to find supporting a false conclusion. Lord Kelvin's careful and multiply supported lines of reasoning arguing that the Earth could not possibly be so much as 100 million years old, all failed simultaneously in a surprising way because that era didn't know about nuclear reactions. But most of the time this does not happen. On the other hand, bad arguments for true conclusions are extremely easy to come by, because there are tiny elves that whisper them to people. There isn't anything the least bit more difficult in making an argument terrible when it leads to a good conclusion, since the tiny elves own lawnmowers. One of the marks of an intellectually strong mind is that they are able to take a curious interest in whether a particular argument is a good argument or a bad argument, independently of whether they agree with the conclusion of that argument. Even if they happen to start out believing that, say, the intelligence explosion thesis for artificial general intelligence is false, they are capable of frowning at the argument that the intelligence explosion is impossible because hypercomputation is impossible, or that there's really no such thing as intelligence because of the no free lunch theorem, and saying, even if I agree with your conclusion, I think that's a terrible argument for it. Even if they agree with the mainstream scientific consensus on anthropogenic global warming, they still wince and perhaps even offer a correction when somebody offers as evidence favoring global warming that there was a really scorching day last summer. There are weaker and stronger versions of this attribute. Some people will think to themselves, well, it's important to use only valid arguments. But there was a sustained pattern of record highs worldwide over multiple years which does count as evidence, and that particular very hot day was a part of that pattern, so it's valid evidence for global warming. Other people will think to themselves, I'd roll my eyes at someone who offers a single very cold day as an argument that global warming is false. So it can't be okay to use a single very hot day to argue that global warming is true. I'd much rather buy a used car from the second person than the first person. I think I'd pay at least a 5% price premium. Metaphorically speaking, the first person will court-martial an Allied argument if they must, but they will favor Allied soldiers when they can. They still have a sense of motion toward the right final answer as being progress, and motion away from the right final answer as anti-progress, and they dislike not making progress. The second person has something more like the strict mindset of a mathematician when it comes to local validity. They are able to praise some proof steps as obeying the rules, irrespective of which side those steps are on, without a sense that they are thereby betraying their side.